is a soft, relatively heavy metal, noted for its rarity, color, and resistance to oxidation. In appearance, pure gold is bright and slightly orange-yellow. It is soft, malleable, and quite ductile. Gold can be pulled into a wire only 1 atom thick, or pounded into a thin foil. Gold appears yellow because it absorbs blue light. Gold is considered a noble metal because it does not rust, nor lose its luster, is the only yellow metal, is the most non-reactive of all metals, and is the heaviest and densest monoisotopic element in the periodic chart. Originally occupying position number 197 in the Opit System Elementov periodic chart, first conceived by the Russian scientist Dmitry Mendeleev, later shifting to position 199, and finally arriving at position 79 in the modern periodic chart. Gold is designated by the letters Au, which derives from the Latin word aurum, related to the goddess of the dawn, Aurora. The word gold itself comes from the Old English word giello, meaning yellow. Gold is produced through supernova nucleosynthesis, beginning with a substance called the quark-gluon plasma. This was matter which came into existence at about 20 microseconds after the so-called Big Bang event in a process known as Big Bang Nucleosynthesis. This quark-gluon plasma was separated by the hot expansion of the universe until the pieces of quarks at last reformed into hadrons. A hadron with 3 quarks makes a proton, forming hydrogen and helium, at around 500 million years after Big Bang. As the hydrogen and helium gathered into gas clouds under gravity and coalesced into stars, stellar nucleosynthesis began, wherein lighter elements are crushed by gravity until they fuse into heavier elements. Stars fuse hydrogen into helium, then they fuse helium into the next heaviest element, lithium, the lithium into beryllium, the beryllium into boron, and so on. But stars can only produce elements through fusion to the element iron, at which point the pressures necessary to form heavier elements ceases. This is why stars have iron cores. They are unable to produce any elements heavier than iron. When a star dies and explodes as a supernova, the intense pressures fuse the iron-nickel at their cores into elements heavier than iron. Gold is one of the products of a supernova, or alternatively from an exploding neutron star. Both can produce gold. Ordinary stars cannot. When the Earth formed during what is called the Hadean period, it was at first an accretion disk of space junk that slowly coalesced into a hot sphere. The heaviest elements such as iron and gold sank to the emerging planet's core, while lighter elements such as aluminum and lithium remain closer to the surface. Volcanoes and magma hotspots have transported gold to the Earth's surface, where it is occasionally found either as nuggets or in tiny slivers called placer gold. Mining operations sift through lighter rocks to locate the relatively heavier gold. The richest gold deposits on Earth are at the Witwatersrand Basin in South Africa, producing some 22% of all gold mined, and which was formed when one of the largest asteroid strikes on Earth some 2 billion years ago formed the structure. All the gold ever mined would fit inside an Olympic-sized swimming pool, or as a cube 21 meters or 69 feet on a side. Gold is naturally present in the human body in tiny amounts. If you were smelted down, you would produce just under 1/3 of a milligram of pure gold.